Hi, I'm Adnaan. I specialise in artificial intelligence at university. In this series of 10 videos, I'll introduce you to key aspects of artificial intelligence and machine learning. Video 2. Defining artificial intelligence. What is a neural network? In order to successfully analyse the impact of artificial intelligence, it is important that we are not ignorant on the mechanisms and functions behind these technologies so that we can effectively better understand how they can be used in society. Therefore, this part of the dissertation aims to achieve the general idea of how artificial intelligence functions, with a particular type called a neural network being explored. While the field of computer science is relatively new, firmly becoming a subject of study during the 1950s, ideas of artificial and mechanical beings in antiquity can be dated back to the ancient Greeks and further, such as myths surrounding the giant bronze automaton Talos and Pandora. In Greek mythology, the story of the automaton Pandora, created by the god of metallurgy Hephaestus, opens a box to release all the evils of humanity, which parallels modern apprehensions of the misuse and miscontrol of artificial intelligence. Millennia later, John McCarthy coined the term artificial intelligence in 1955 as the name of the field of study concerning ideas of abstract machinery, cybernetics, and information processing. Briefly put, artificial intelligence, often abbreviated to AI, is a broad term concerning techniques such as machine learning in the field of computer science which concern the replication of thinking or intelligence in computers. Traditionally, computer programs are written in algorithms in the form of basic instructions in which a human, called the programmer, describes how to perform a task to solve a problem. One basic algorithm could be describing the behavior of a primitive traffic light. The programmer would code the computer to start with the lights at green, then change to amber, followed by red after a duration has passed. Some simple tasks like this can be easily programmed into a computer by a human, but when the task is to navigate roads, identify hazards and oncoming objects for a computer system in a self-driving car, manually coding every possible condition and circumstance for the computer is inhumanly possible. In the field of AI, the goal is for the computer to solve a problem by extrapolating a solution from the information given, learning from experience. In this way, AI allows machines to solve problems not per algorithm, but with a learning algorithm which facilitates them to solve a range of complex tasks. Artificial intelligence technologies are typically split into two branches, general AI and narrow AI. Narrow AI usually concerns solving only a single task in which the system learns from existing data. For example, in electronic assistants such as Apple's Siri and facial recognition software. Currently, all applied use of AI technology are under this category. Moore's law, named by Intel co-founder Gordon Moore, dictates that every 2 years, the computational power of available computers doubles due to smaller and more economical transistors being able to fit on computer chips. This, combined with huge amounts of data now available from sources such as weather satellites and social media, have enabled the rise of commercial AI use to occur in the past decade. Artificial general intelligence regards solving a range of different problems which, in theory, could be performed by an intelligent human. Fully realized AGIs have yet to be created but experts estimate that AGI could be developed as early as the 2040s. One implementation of artificial intelligence in the form of machine learning, which imitates some of the mechanisms of the human brain, are neural networks. The workings of the brain are often informally described as being the biological correspondent of an electronic computer. The brain consists of over 100 billion cells called neurons, which contain various extensions termed dendrites, which act as inputs of electrical impulses through the neuron to the axon, which outputs an electrical impulse to another neuron. Similarly, the circuit boards in a computer consist of tiny switches called transistors that act as logic gates, which are the far equivalent of neurons in the biological brain. where the most cutting-edge microprocessors contain over 2 billion transistors. Beyond these similarities, the comparisons between the brain and computer end, as the structures and wiring of the components differs vastly. Essentially, the thought process between them is completely different. The transistors on a circuit board operate as simple logic gates between each other, transferring electric charges to each other in simple arrangements of a couple hundred million. On the other hand, neurons are densely interconnected in more complex ways. One neuron may be connected up to 10,000 others nearby. The architecture of computers is efficiently designed to encode, retrieve and apply transformations to large amounts of data. In contrast, brains encode information much slower through a process called learning, taking months and years to make sense of complex ideas. Though this is not to imply that biological ways of storing data are inferior, as it is speculated that were all information in every computer coded onto DNA, it would fit in the back of an SUV. The benefit of Mother Nature's brain is that the adaptive nature of how strength of the connections between each neuron can change allows for distinct bits of information to be put together spontaneously to produce creativity. It is the structure of our neurons that are responsible for our ability to create art, music, and question the nature of reality. Therefore, the premise of a neural network is to model the architecture of the brain so that a computer is able to replicate the biological processes of recognizing patterns by learning and making decisions. However, it is important to note that neural networks are run as simulations on software. That is, standard architecture computers are programmed to behave as if they were made up of dense, interconnected cluster of neurons working in parallel, since, as yet, there has been no successful attempts at building a computer with transistors that are wired in the same adaptive nature of the brain. As a result, in truth, the only real neural network are those which appear in the brain, and the neural network models implemented on computers are simply artificial neural networks. This is the distinction of human intelligence and artificial intelligence. Remember to subscribe to this YouTube channel for the next video in this course and my future videos in all aspects of machine learning.